Hello everyone, in this video I'm going to discuss the parametric differentiation. So given that x is equals to 1 over 1 plus t squared and y is equals to 1 minus t squared over t, where t is a non-zero parametric. Show that the first derivative is equals to 1 over 2 bracket 1 plus t squared over t power of 3. Hence, find its value at the point half 0. So before we start to differentiate the situation, I might need to differentiate or modify the situation. So I might need to modify the situation. So where x will be equals to 1 plus t squared power of negative 1 and y will be equals to 1 over t minus t. Or we can say y will be equals to t to the power negative 1 minus t. Next, we are going to differentiate dx dt equals to negative 1 plus t squared to the power of negative 2 bracket 2t. If we simplify the situation, and we will have negative 2t over 1 plus t squared to the power of 2 for dx dt. For the y, we will have dy dt, where we will have negative 1 over t squared minus 1. If we simplify the situation, so dy dt will be equals to negative 1 minus t squared over t squared. Or, next we're going to find the first derivative, where we will have dy dx is equals to dy dt multiply with dt dx. So substitute, we will have negative bracket 1 plus t squared over t squared multiply with dt dx. So in this case, we need to flip the situation. So where we will have 1 plus t squared power of 2 over negative 2t. So finally, dy dx will be equals to 1 plus t squared to the power of 3 over 2t cubed. So now, based on the situation, kindly modify the situation. So we will have dy dx, factor out the 1 over 2, bracket, we have 1 plus t squared over t to the power of 3. So in here, we already show that the first derivative is equals to 1 over 2, bracket, 1 plus t squared over t to the power of 3. So we can write shown. So now the second part is find its value, meaning that the value for the gradient or the dy dx at the point half 0. So before we can find the value dy dx, we need to determine the value of t. So meaning that in here, x is equals to half and y is equals to 0. So by substituting the value into x and y in order to determine the value of t, so we will have 1 over 2 equals to 1 over 1 plus t squared. Simplify the situation, and we will have 1 plus t squared equals to 2. So t squared minus 1 equals to 0, where we will have t minus 1 bracket t plus 1 equals to 0. So the value of t will be equals to 1, t will be equals to negative 1. Next, we are going to substitute the value y equals to 0. So in here, we will have 0 equals to 1 minus t squared over t. So in here, 1 minus t squared is equals to 0. So 1 minus t, 1 plus t equals to 0. So finally, t equals to 1, t equals to negative 1. So in here, we notice that both values are valid. So now it's time to substitute the value of t into the first derivative. So when t is equals to 1, the dy dx will be equals to 1 over 2 bracket 1 plus 1 over 1 to the power of 3. So in here, we will have 1 over 2 bracket 2 to the power of 3, where we have 8. 8 divided by 2, we will have the value of dy dx is equals to 4. So for this case, if the value is equals to negative 1, the first derivative will be 1 over 2 bracket 1 plus bracket negative 1 to the power of 2 over negative 1 bracket power 3. So in here we will have 1 over 2 bracket 2 over negative 1 to the power of 3. So we will have 1 over 2 bracket negative 8. So finally, the first derivative value will be equals to negative 4 if t is equals to negative 1. So here we are, and thanks for watching.